Hello and welcome to this online video lecture about electronegativity. Probably one of the more important properties in terms of elements with chemistry because it has a lot to do with bonding and the formation of compounds. So by the end of this lecture, you should have a fairly good understanding of what electronegativity is a measure of, and you should be able to, given a set of elements, compare them in terms of electronegativity, figure out which one would be the highest, which one would be the lowest, etc. So if you watched the lecture, the advanced topic lecture on periodic trends, electronegativity was one of those. And we defined it in there, but let's just kind of do it again in case somebody's bopping into this lecture without watching the other one. Electronegativity is an element's ability um, to attract a shared electron, to attract. So if an element combines with another, like let's say that carbon combines with hydrogen and they're sharing an electron right here. They're actually sharing two electrons right there. The electronegativity is a measurement of each one of these atoms' abilities to attract those shared electrons. And sometimes if the electronegativity difference is high enough, one of the atoms will end up spending more time with the electrons zipping around those than the other one will. And so when we get into bonding, we're going to be talking about electronegativity and what it means for the bond that's formed. But before you get there, it's really important that you can look at the periodic table, you can look at the elements given, and you can decide which one has a higher or lower electronegativity. So the general pattern here is that the highest electronegativity is in the top right of the periodic table, and the lowest electronegativity is in the bottom left. So fluorine has the highest and francium has the lowest. And we're ignoring the noble gases because the noble gases in group 18, they don't form compounds readily. So we're just going to ignore those. So you have two trends. The one trend is that as you go from left to right across a period, electronegativity increases. And this is the stronger of the two trends. So usually you can be pretty sure that if an element is to the right of another element, especially if they're in the same period, you can be pretty sure that the element to the right is going to have the higher electronegativity. The other trend is as you go down a group or down a family, the electronegativity tends to decrease. The atoms are getting larger and it's harder for the atom's nucleus to attract that shared electron or those shared electrons. So as you go down a group, usually the electronegativity gets smaller, decreases. This is the weaker of the two trends, and sometimes the change is very, very small, and so it's probably better to say that the electronegativities are similar within a group, and if anything, they just get a little smaller as you go down. Okay, so what does that mean for you? Well, if I give you two elements, like let's say I gave you magnesium and I gave you oxygen, and I asked you which one of those two had the higher electronegativity. This one's a pretty easy one because if you look at this, I gave you a metal, magnesium is a metal element, and I gave you a nonmetal, oxygen is a nonmetal element. So anytime you're comparing the electronegativities of two elements and one of them's a metal and the other one's a nonmetal, it's a pretty sure bet that the nonmetal has a higher electronegativity and that the metal has a lower electronegativity. If you look on the periodic table, if you wanted to double check that general rule, magnesium's over here, it's in group 2, and oxygen's all the way over here in group 16. So remember, the stronger of the two trends, while magnesium is below oxygen and electronegativity goes down, oxygen's all the way over here to the right of magnesium. And that's the stronger of the two trends. As you go right, the electronegativity tends to go up. So it's a pretty safe bet. Oxygen has a higher electronegativity than magnesium does. Sorry about that. And indeed, anytime you see this pattern of comparing a metal to a nonmetal, like if you had sodium, oh my gosh, sodium and sulfur, that pattern tends to hold. The metal usually has the lower electronegativity, and the nonmetal usually has a higher electronegativity. So what if you have two metals or two nonmetals? Then you have to kind of use the patterns a little bit more. So if I gave you lithium and let's say barium, you'd have to find those in the periodic table and remember the patterns that we just talked about and try to figure out which one would probably be the higher of the two electronegativities. Lithium's all the way up here and it's in the first group, and barium's all the way down here, it's in the second group. So barium's to the right of lithium, but it's also much further down in its group than lithium is. Now normally you would say, well, barium's to the right and that pattern's stronger, so it must have a higher electronegativity. But the problem is, look at how much further down in its group barium is than lithium. And it's only one group over to the right. And so because barium's so far down here compared to lithium, it's actually got a lower electronegativity, and lithium has the greater one. So lithium's electronegativity is greater than barium's is. So you're probably asking yourself, okay, well, great, where's the cutoff? Well, that's the thing. These are general patterns, and it's not always that clear cut. There are periodic tables, however, that have the electronegativity right on them. And later in the course, you'll probably need to use those. But for now, I'm not going to ask you any questions that are close enough that you might be kind of confused. I'm not going to ask you like potassium and strontium because they're kind of right next to each other, and that would be pretty difficult to figure out because of the weakness of the two patterns. So that's it. If you have an element that's further to the right across the periodic table, its electronegativity is almost always higher. And then as you go down groups in the periodic table, the electronegativity tends to go down, or it tends to kind of stay equal. And if you just remember those two major guidelines, along with the metal-nonmetal pattern that we talked about up here, then you should be able to basically rank any elements and put them in order based on their electronegativity. So let's do a couple. Let's do a bunch of elements. Let's do lithium. Let's do fluorine. We'll do carbon. And then we'll do, let's say rubidium. And see if we can figure these out and put them all in order from lowest to highest electronegativities. Let's find them on the periodic table. Let's see, lithium is right here. Then we've got fluorine up here in the top right corner. Carbon is in the same period as fluorine, it's just over to the left. And rubidium is a metal all the way down here. So basically what we have two metals and we have two nonmetals, and we know that the general pattern there, let me just scroll up real quick and see, I want to use the same colors. The general pattern there is that the metals tend to have lower electronegativities than the nonmetals. So it's a pretty good bet that lithium and rubidium are going to be in the front of our list, and fluorine and carbon are going to be towards the top of our list as having higher electronegativities. So let's see if we can figure out what order they should be in on the two ends that they're at. Lithium is at the top of its family, way up here, and rubidium is in the same family and further down. And so we learn the general pattern there is as you go down, the electronegativities tend to go down. So the lowest of these two is probably rubidium. So we're going to put rubidium first. And then we're going to put lithium. And now we have to figure out the nonmetals. And if we look at the nonmetals, we see that they're in the same period here. And fluorine is further to the right than carbon. So that means that fluorine's electronegativity is higher than carbon's. So it's then going to go carbon as the next highest, and then fluorine is the highest of that group. There you go. So that's basically how you use those general rules to try to figure out the electronegativities of elements when you're trying to compare them. Thanks for watching, and as always, if you have any questions, feel free to ask in class.